Okay, this time we're going to carry on from the last video where we were talking about displacement reactions of metals, and we're going to talk about the same kind of thing. So we're talking about extracting metals. So we're going to talk again about the ore. So we dig up the ore from the ground. Remember, an ore is just a rock. Okay, so if we have a metal ore, that's just a rock containing a metal. So we dig up the metal ore out of the ground, and we need to extract that metal from the metal ore. So we can do that by using the principle that we learned last time, which was that more reactive metals can be used to displace less reactive metals. Okay, and so when we're talking now about displace, displace has the same meaning now as extract. So if we think about one of the examples we did last time, so if we go back and we look at, say, this example here, we can see we've got this compound of copper. Now we want the copper. So we use magnesium, which is a more reactive metal, to displace the copper, to make magnesium sulfate, and then we get the copper that we want. So we have extracted the copper from the copper compound. So we can't use this copper here because it's in a compound of copper sulfate, but now that we've extracted it, we can use it. All right, so magnesium displaces the copper because it's more reactive. So here I've got the reactivity series. So you'll remember that up here, these are more reactive metals. And down here, these are less reactive metals. So let's imagine that I have dug up some copper oxide. So I've dug up this copper oxide out of the ground, and I want to extract the copper from the copper oxide. So what I do is I look at my reactivity series and I can see copper is right down here at the bottom. So that means that I can use any of these metals to extract copper from the copper oxide. So I could use iron to extract my copper oxide. However, I don't want to do that because I need to use my iron to make things like bridges and buildings and that kind of thing. So if I use the iron to extract the copper, yeah, I get my copper, but I lose my iron, which is not good. So I could use a different metal. So I could also use aluminium, but I don't want to do that because aluminium is a really good metal. It's very strong, it's very light. Okay, you can use it to make all sorts of useful things. But if I use aluminium to extract my copper, yeah, I get my copper, but I lose my aluminium. So this is a problem, is that if we want to extract one metal, we lose the other metal. However, there is a solution to this, and you'll see that I've left a gap here, and that's because right here in the reactivity series, we have carbon. Okay, carbon, like is in charcoal. All right, so the coal that you dig out of the ground. Now, we've got lots and lots of that. It's really, really cheap. All right, and therefore, because of those two reasons, okay, we have a plentiful supply compared to these metals, and it is very cheap. It means that we can use carbon to extract metals. Now, which of these metals can we use carbon to extract? So have a little think about that. Which of these metals can we use carbon to extract? Right, so carbon can extract all of these. Okay, so it can extract these. Now, why can these metals be extracted by carbon? Because they are less reactive than carbon. All right. However, these guys up here, these guys here, these cannot be extracted by carbon because they are more reactive than carbon, so it won't work. All right. So let's see how this reaction looks. So we take our copper oxide, and I'm going to react it, so it's in the solid state. I'm going to react it with some solid carbon, all right, just like charcoal. Heat it up, and you get your copper metal. That's what you want. You've now extracted your metal, and the other product you get is, well, the oxygen. So the copper is displaced. So carbon displaces the copper, so we get carbon, and it's carbon dioxide is what it makes. Okay, so you see how the carbon has displaced the copper, so it's now carbon and oxygen, and we just get copper by itself. Excellent. So that equation is not balanced. All right, pause it now, balance that equation. Okay, so you should have got that it was 2 copper oxides because you need to balance your oxygens, and if I've got 2 copper oxides, I need to have 2 coppers. Okay, and this is the same for lead. So if I have lead oxide, I can extract that using carbon, and that will give me my lead plus my carbon dioxide, and that's going to have the same balancing as the one above it. All right, let's do one more. Okay, let's do iron. All right, now iron isn't like these, so these are CuO, PbO. Iron is Fe2O3 plus our carbon. Okay, now I want you to write in the products that I'm going to get and then have a go at balancing the equation. Okay, so pause it now and have a go at that. All right, so you should have got that you extract your metal, so you get your iron, and you get carbon dioxide. So even though this compound here is slightly different, it's the numbers of iron atoms, the number of oxygen atoms are slightly different, we still get the iron that we want, and we still get the carbon dioxide as a product. All right, now this reaction is done at very high temperature. In fact, it's so high temperature that the iron comes out as a liquid. All right, and now we need to balance it. So if you haven't managed to balance it, have another go now. Okay, so you should have got that this was 2 in front of there, 4 in front of there, and 3 in front of there. And this equation here is done in a piece of equipment called a blast furnace, which you might have heard of. But that's where, that's the piece of equipment, and you can look that up and you can see pictures of that and what that looks like, but it's produced in a blast furnace. Okay, so nice and straightforward today because it's essentially the same thing that we did last time. It's just these are all displacement reactions where the more reactive element displaces the less reactive element. Okay, but this time, instead of using a metal, we're using carbon. Okay, and we're not going to go into it now, but we'll do it at GCSE, how you extract aluminium, because you cannot use carbon to extract aluminium. All right, because aluminium is more reactive than carbon, so we need to use a different method to extract that. Okay, good work.